So we're now in part 2 of our case study applying completion stage methods, and we'll finish off the rest of this example and see how it works. So this part's going to talk about other methods, particularly focusing on the concept of a collector, which we will talk briefly about. So this is where we left off before. Remember, we had a stream of completable futures to big fractions, a stream of completable futures to big fractions that came out of map. And now what we want to do is we want to use the collect method, which you've seen before in the context of sequential and parallel streams. In this case, it's a sequential stream. And we're going to go ahead and return a single completable future to a list of big fractions that at that point have finished being reduced and multiplied. But when we get the completable future back, those computations are all taking place in the background in the common fork join pool. So it's really a very interesting model. And again, this is very much like your assignment number 3, where you do a bunch of asynchronous computations, in your case, crawling through a recursive directory structure on your machine or in the web. And you want to get back a single completable future that will trigger when all the other computations are done, crawling and doing other things in that context. So we get back a single completable future. And then what we do here when we're done is we go ahead and after all those computations are finished running in the background, the thenAccept method is called. Remember, thenAccept is always used at the end of a chain of completion stage methods. And we pass in a method reference to a method that will sort and print the list of results when all the asynchronous computations complete. This is just the coolest thing ever. So let's take a look at this particular method. This is a really fun method too. So this is a variant of what we had talked about earlier when we had talked about the acceptEither completion stage method that is triggered when 2 previous stages complete. And you can see what happens in this particular case is sort and print list takes a list of big fractions, which is what is going to result after that one completable future triggers, and we have a list of results. And we're going to sort and print this list of reduced and multiplied big fractions. And the way we do it, as we had talked about earlier, is we're going to go ahead and asynchronously quick sort the list. Likewise, we're going to asynchronously merge sort the list. So both those things are going to be running in the background. We get 2 completable futures back, quick sort F and merge sort F. And then we go ahead and use the acceptEither completion stage method to say, whichever one of these 2 computations finishes running asynchronously first, take the result, which will be a sorted list, and do something with it. And this is kind of interesting. If the future is already completed, if by some twist of fate, maybe you had a very short list to sort, for example, if by the time the quick sort F or merge sort F completable future is done, by the time acceptEither is called, then this computation will run in the thread that registered the action. It'll run in the calling thread. However, if it takes a while to run and acceptEither has to be called back later, then the thread that runs this computation, the one that is highlighted in red, will run in the thread in which the previous stage ran that has just completed. So these are all sort of implementation details. I'm just explaining to you how things work under the hood because it's kind of interesting. So again, just to reiterate, if the future is already completed by the time, if either future is already completed, so one of them is completed, by the time acceptEither is called, then this action is run in the thread that registered the action, in other words, the calling thread. If they're not done, then that computation runs in the thread for whichever completable future finished first. As before, as we talked about before, acceptEither does not cancel the second future after the first future completes. And the reason for that, once again, is because that completable future could very well be needed for some other computation somewhere else in the program. That's perfectly legitimate. And so we don't want to kind of conflate the behavior. We don't want to mix what's called policy and mechanism. Just because acceptEither doesn't want it in this call doesn't mean someone else doesn't want it. So it doesn't go ahead and call it to cancel it unilaterally. Not all asynchronous frameworks work that way, but CompletableFutures works this way. So if you want that thing canceled, you'd have to cancel it yourself. Probably overkill, but you could. And the reason it would be overkill is because, as we saw earlier, canceling a CompletableFuture by default doesn't really do anything other than indicate nobody can get the result. It doesn't stop the computation for various mysterious implementation reasons. OK, so that's the end of our coverage of applying completion stage methods.